Hi everyone, I thought I'd make some videos so that I can go through some ways to solve some problems and sort of explain my my reasoning or my thinking behind solving some issues, some problem solving things in programming. So I'm just going to be programming in here, allowing you to see and explaining my thought process along the way when I solve some of these problems. So lots of people asked about how to solve the problems in the assess lab and how to do some of the other workshop questions. So I'm going to solve some similar ones, but not the same ones, and then just explain my thought process. Okay, so the first one is I want to compute a table of numbers given n as input and the output will be n cubed. So for this one, I'm just going to call it 1.c. So I'm going to make all of these available online. So let me just print out this. Number one. So question one. So this will be question one. Oops. And all of these will be available at my GitHub page. So github.com/luke611/1806 ICT examples. So let me just write that. So yeah, as I go along, you should be able to see all of my output as I go. So yeah, let's get started on the first one then again. So I want to generate that table of numbers. So let me start with n as 1. I can start n as 0. And then 4 from n is 0. We don't need to retype that. So n less than, let's just say 20, n plus plus. Then we can print out n, and then the value of n to the power of 3. This will be this. So I'll just print out two integers, n, and n times n times n. Oops. So yeah, then we have the n going down this column, and then we have n cubed here. We can print out that in sort of like a table format by printing out maybe some stars like this. The puts function does the same as printf, except it doesn't allow you to put any input in here, but it also adds the new line, so you don't have to write the new line character. So I'm gonna put that, and then I will print out n, and I'm going to use the tab character to tab it over. So then I'll print out output, then I'll print out one of these, and we'll see what that looks like. So I'm going to put some more stars there like that, and then do the same here. And then over here I will put a tab here and put two tabs there, and we'll see what that looks like. So that gives us something like looking like a table. So yeah, that's how I would solve this. So just going up in a loop and then printing out n and n times n times n, and then putting in the integer and then I've just basically done a bit of formatting with the tabs and this around it to make it look more fancy. Okay, so the second one that's done. The second one is computing the factorial of n. So the factorial of a number, for example 3, is equivalent to 3 times 2 times 1. So if I get given n as, for example 3, then the output should be 3 times 2 times 1. If I give 4, then the output will be 4 times 3 times 2 times 1. So it's basically just going back through until you get to 1 and multiplying all those. So let me have a for loop here that I'll start with n equals the factorial number, n equals f. Whilst n is larger than or equal to 1, I'm going to go backwards this time in the for loop. And then I'm just going to print out these so that I can see what I'm doing. Yes, I need to change this to factorial. Okay. And I need this to print out n, and I also need to create n as well. So yeah, so now we've got our 4 times 3 times 2 times 1 there. So to get the factorial, I'm going to create another variable called output, and I'm going to set it to the identity for multiplication. So if I set it to 0 and I multiply it by each time, anything multiplied by 0 is just going to be 0, so I'm going to set it to 1. So then I'm going to set output equals output times n, and then I'm going to put this at the end and say factorial of this equals this. Here I'll put f, and here I'll put output. So if I run that again, factorial of 4 is 24, factorial of 3 is 6, and so yeah, factorial of 2 would be 2 times 1, which is 2. So in this way we can compute factorials of different numbers. There we go. And it's usually actually written like this. This equals that. So factorial of 10 is 3,628,800. Okay, so that's that one done. I'll put these, oops, I always do that. I'll put these up. Okay, so the next one is this one, list the factors of a number. Okay, so let me change this, and I'll call this one factors. Okay, given a number n, so let's just say 60, I'll list all the factors. So the easiest way to do this is to start off with I as 1, and having a for loop until I, whilst I is less than or equal to n, and going up and testing each number. So if this number I divides evenly into n, then that means we know that we have a factor. So if n mod I equals 0, so if n divided by I has no remainder, then we know it's a factor. So we can put I is a factor of this, in which case we'll put I and n there. Oh, 16. Okay, so 1 is a factor of 60, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, 60. We can also put in which number you need to multiply that number by. So we can put this number times this number equals this. So I times n divide I equals n. So 1 times 60 is 60, 2 times 30 is 60, 3 times 20 is 60, etc. like that. Okay, so that's getting the factors. Testing even numbers we can do is also very easy. So let me type in, give a new evens. So let's have a max variable, which is 100, say. And then we'll start at I. I is 1. I less than or equal to max var. And this time we want to check whether I is even. So if I divides, if 2 can fit into I evenly, then we know it's even, right? So if we go I mod 2, so if I divide 2 has 0 remainder, then we know it's even. Is even. And yeah, that's all there is to it. So if I run this, evens, 9 is even. Okay. I is 1, I less than or equal to this. I plus plus. Ah yes, I forgot to put in the I see. Okay, so basically now we're listing all the even numbers. So 2, 4, 6, 8, 10, 12, blah blah blah. If you want the odd numbers, then you can do that, or you can set this to 1. So if I divides into, if 2 divides into I with 1 left over, then it must be odd, right? But I'll just leave this for now, and we'll move on to the next question. So if a number is a prime number, so a number is prime if there are no other numbers that can divide into it apart from itself and 1. So in this case we have the number that we're testing for. Let's check if 7 is prime. We can go from I is 2, we don't have to test with 1, I is less than n I plus plus, and then let's print out all these numbers so we can test. We're editing our evens. Is even. Okay, and then let's change to a new file and call it factors. Let's see. Oh no, is prime. Let's see. Sorry, is prime. Let's see. Okay. So we'll start off as our n is 7, and our for loop will range from 1 less than 7. So excluding 7, then let's print out that. Those numbers. Sorry, start off at 2. Here's prime. So yeah, so we're going to test these numbers to see if they're if they divide into n evenly. If n divide I equals 0, then this is not prime. Okay, so let's check a number that that isn't a prime for this. So here we can see that it's printing out not prime twice. So instead of doing something like that, what we actually want is to start from the assumption that it is prime, and then as soon as we find out it's not prime, then break and leave this for loop. So if I run this, then it's only printing not prime once. So 110, which obviously isn't prime, we're making sure that we're just printing not prime one time by breaking out of the for loop straight away if we need to. If we want to print out that it is a prime, then we can simply have a variable here that is called isPrime, and we'll assume that it is prime, so we'll set it to 1 or true. And then here, if we find out it's not prime, we'll say isPrime equal 0. Then down the bottom we can have if isPrime, then print out it is prime. Actually, it's better to use printf I is prime. Otherwise, we want to print out that it's not prime. Else, I is not prime. So yeah, 110 is not prime. 13 is prime. Okay, so next question. X. A program that converts number 54, so a number like this, or 545 to 545, the words. So let's call this one number 2 word .c, and run this. Number 2 word. Okay. So for this one, we're starting off with some number n equals, and then in our example we have 545, and let's say we want to extract this digit from here. So basically what we need to do is, given 545, we want to extract this digit, which is in the hundreds column. So what we can do is we can take 545 and divide it down by 100, and that shifts the decimal place over to here. And then if we convert this to an int, then it simply removes that 0.45. Then in case we had any numbers that are at the front here, like 26, and we have 26 there, 26 there, we want to just extract the 5, right? So we can then mod that by 10. So any part that goes over 10 will be removed. So 265. So convert that to int, and then mod it by 10. That gives us the 5. So the formula for this is we can get the digit of n by dividing it by that column. So ones, tens, hundreds. So hundreds, then modding it by 10. So hundreds column of I is I, where we can go hundreds column of n is d. And so let's test this. So we can see that's 5. And if we put 2 6 here, then that is also 5. If we put this to a 3 and then recompute it, we can see that it's 3. So a more general formula is if we want the third number, so 1, 2, 3, then we can put this 10 to the power of 3 here. So 10 to the power of 3. Let me just convert that back to an integer and include math.h to use that. So yeah, that's getting out the 6 column base, the number 6. Sorry, based on 10 to the power of 2. So yeah, 10 to the power of 2 would be 100. Yeah, so that's getting out the 3. If I put 0 in here, then I should get the first one, the 5. If I put 1 in here, I should get the second one, the 4. Whoops, I forgot to save it. The 4. If I put, I already tested with 2, so if I put 4, then I should get 1, 2, 0, 1, 2, 3, 4. I should get the 2. So yeah, that's getting out all the different ones. We can see how many digits are required to test, actually. We can see how many digits there will be in a number. We should be able to use the log function for that. So int num digits equal log of n. So in this case we have 1, 2, 3, 4, 5 digits. So let's print out I has digits, D has num digits. So 2 has 10 digits. So it actually only has 5 digits. So let me just try 10. So make sure it's giving me log 10. So I should have this plus 1 digits, I guess. So whoops. N has 5 digits. So let's just test this. 1, 2, 3, 4, 5. That's 5 digits. 5 digits. 6, 7, 8. That's 8 digits. So because before log is actually giving me the log of the natural number instead of log base 10, so that's why I just divide it by log 10 to get that. But if you want, you can just remember this formula. And then carrying on with our problem, we're converting all of these numbers. So let me go down here and have a for loop starting with I. And we don't need these ones, but I will use num digits. So starting with I at num digits minus 1. Whilst I is less than greater than or equal to 0, we're going to go backwards here. So here I'll just print out I to make sure we're doing the loop properly. So here let's just test with 1, 2, 3, 4. Here we're going 3, 2, 1, 0. So this will be 3, then 2, then 1, then 0. And then let's add up those numbers. So first we need to extract the digit out. So digit equals n divided by 10 to the power of I. And convert that to an int. And then multiply 10. Okay? So let's get that digit and actually let's print it out here. So the numbers we're adding up are 1, 2, 3, 4. If I put these as 5, 6, 7, 8, 5, 6, 8, 9, 2, 5, 3, then 5, 6, 8, 9, 2, 5, 3. Now we need some sum variable, so I'm going to set it to the identity for addition, which is 0. And then I'm just going to say sum plus equal d. Then I'm just going to remove this and print out sum of digits of I equals I, where that is n and this one was sum. So sum of these digits is 38. If I put 1, 2, then that should be 3. Sum of those digits 3, etc. So I'll put this up, and we'll break this video up so that the rest of these 7, 8, 9, and 10 are in a different video. Okay, thank you.